Okay, everyone, welcome to the Noisebridge Python class. This is lesson 4. This class meets at 7 p.m. on Mondays at Noisebridge in San Francisco. You all know that who are here because you're here in San Francisco and it's 7 o'clock. Generally, if you follow the links on the wiki, you'll see more information about the class and you'll see the upcoming schedule. Currently, we are repeating every lesson 2 to 3 times by doing like lesson 1, 2, 3, and then 2, 3, 4 with certain enrichment exercises interspersed in between. So we'll continue with that sequence because it seems to be going pretty well. So today we're on lesson 4. This is the first time we've covered lesson 4 of this series. We're going to talk about for loops and the more, quote-unquote advanced usages of break and continue. Then we're going to talk about function stuff, basically how to define positional and keyword arguments for functions, function scope, so to speak, and then we'll talk about star args and, this is a mistake, star quargs. Which are special arguments that you can, or special parameters that you can define with your functions to do special things. So let's get started. So for loops, we've seen a basic for loop. This is a list of fruits. And then when we use a for loop to iterate over the list, we say for fruit and fruits. So each fruit in the list is sequentially assigned to the fruit variable. And then inside this for loop, we print you have a fruit. So as each fruit gets passed into the fruit variable, we print that fruit name. Then we go back to the top and get the next fruit, etc. So we see this. I'm not covering this too deeply because, like I said, we've technically already seen it. So what's this break keyword? We can use break to immediately stop the execution of a for loop, and it jumps to the end of the block. This is like, maybe we've found something we're looking for, or we otherwise don't need to keep processing things. Maybe you're reading data from a socket because you're a web server, and then you see the data that you need, and you say break. I don't need to read any more data. So you break out of the for loop, out of it. You were in it, and now you're out of it. So here I have a function called hasFruit. And it does a for loop for fruit and fruits. And if the fruit is equal to the fruit that we passed into the function, it tells you have that fruit, and then we have the break. Otherwise, if the fruit is not the fruit we're trying to find, it says, nope, it's a blank, and it continues through the for loop. I am just updating this for my own purposes because I decided recently that we should use f strings for this class rather than percent strings because no one under the age of 40 uses percent strings. I say that because I'm 40. That's why it's a dig at myself, I swear. And then all right, so we have the for fruit and fruits. We're trying to find this fruit. If we found it, we say you have it, and we break. Otherwise, we say nope, it's a blank, whatever it is, right? So we run this code, and obviously right here we are calling that function hasFruit. So we run this code. It says nope, it's an apple, right? Because that was the first fruit. And then it's kiwi. We're looking for kiwi, so it says you have a kiwi. And then it breaks. The for loop is over. Even though the break is inside the if, right, it applies to the for loop. That's actually the thing that confused me most about break statements when I first started doing this, is that this break statement does not apply to this if statement. It applies to this for loop. So if we try it again with lime, we see, nope, it's an apple, nope, it's a kiwi, you have a lime. But notice that it didn't mention the pear, right? So if we edit this, let's say we remove the break, we'll comment it out. Then when we run it, all right, do you see the difference? Now it says, nope, it's an apple, you have a kiwi, nope, it's a lime, nope, it's a pear. Because even though we found the fruit we wanted, we didn't break, so it just continues the for loop. Is it the fruit you want? Nope, it's a lime. Nope, it's a pear. Blah, 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 right? So this is where I pause and say, does this make sense? Are there any questions about the break statement? Okay, we'll move on. Oh, and then this is just a note that obviously, like, this is kind of a roundabout way to find a kiwi in a fruit basket. So what you kind of want to do actually is use this in operator. So it's just so the syntax is just like kiwi in fruits, and it returns a boolean, true or false. So is kiwi in the fruits list? True. Is banana in the fruits list? False. Make sense? And you also use not in. So kiwi is in fruits and banana is not in fruits. This is exactly kind of what people are talking about when they say, like, Python kind of reads like English. It's like stuff like this that they're really talking about. And I should add, you can also use not in. Okay. On the other hand, if we have items in the list that we know we don't need to process, we can use continue. And what continue does, it skips back to the top of the loop and continues with the next item. So it's kind of like, oh, I'm processing a list. Oh, hey, it's an apple. Never mind apple, just continue. Hey, it's a banana. Oh, just whatever, continue. And it's like, oh, it's a cherry. Cherry is the thing I wanted. So now here's like 100 lines of code to process the cherry, right? So this is kind of the alternative to maybe putting the entire 100 lines of code under an if fruit is cherry, equals cherry block, is that you just say if it's not a cherry, just keep processing until you find the cherry. I don't know what my example is. Oh, it's about I'm doubling fruit prices. Okay, great. So, yeah, it's always fruits around here. I find fruits to be just like a familiar and neutral topic to write sample code about. So the fruits have a price now. This is, what kind of data structure is this? We've covered it extensively in the previous 3 lectures. Close, but no. Dictionary, yes. This is a dictionary. And it's mapping fruit names as the keys. It's mapping them with the colon to their price. These are obviously just made up prices and made up fruits. Actually, I think these are real fruits, but And so when we do this for loop for fruit in fruits.keys, this gives us just the keys, apple, kiwi, lime, pear. And we're saying if the fruit is not the fruit to double, then it gives us it logs some info. It says, hey, we're not doubling that fruit, right? And then here is the continue keyword, continue statement, right? So when we continue, again, just like the break statement, the continue applies to the for loop, not to the if statement. So like this could be like nested a million lines down, like whatever, it's applying to the for loop. And so we continue, so we keep going until we find the fruit to double. And when we do, we say fruits slice fruit equals fruit slice fruit times 2 rounded to 2 places. So before we talk more about continue, what does this line of code do? Go ahead.
Makes a new column and it rounds the price of fruit.
It definitely rounds the price of the fruit. I'm not sure what you mean by column, though. There's no columns here. It's just a dictionary.
Oh,
Yeah. This isn't a pandas data frame. It's just a dictionary. Yeah. Go ahead. In the back. Jeannie. Did you raise your hand?
No.
Okay, sorry. Okay, so what we're doing is we're taking the value of the dictionary with the key of fruit, whatever the fruit may be, because we're using a variable to access the dictionary, right? And we're saying assign with the equal operator, assign to that value this new value. And like you were saying, how do we find the new value? Well, we round the price of the fruit times 2 to 2 places, because fruit is the price of the fruit, right? Like fruit, like if I said like fruits apple, what would that be? Yeah, 129. Yeah, exactly. So if I say fruit, it's fruit, whatever the fruit we're on, right? And remember, we're checking, does that fruit equal the fruit we want to double? If it doesn't, we continue. And if it does, we do this assignment to double the price. So here, what we're going to do is we're going to print the fruit dictionary, the fruits dictionary. We're going to double the price of limes, and we're going to print it again. So let's see. Here it is. Here's the dictionary. Here it is with the price of limes doubled. Now it's $1.78. So we see, it worked. And then here's some debug messages that we were printing out. Not doubling apple, not doubling kiwi, not doubling pear, etc. Because if you look, when it iterated over those keys, it encountered the other keys, and those are not the ones that we wanted to double. So we hit the continue statement, and we didn't double them, right? Because what happens when I hit the continue statement? It goes back to the top of the for loop immediately, which is why this code, like if I put this code here, print 42 divided by 0, what is that? That's an error, right? A division by 0 error, right? It's this error, 0 division error, right? So why didn't that error get thrown or raised, whatever, when it hit this code? Never got there. Very good. Exactly right. It never got there. Because when it continues, it goes to the top of the for loop, right? So like I say in this comment, just like an if statement where the condition is false, like we learned back a couple lessons ago, if you have an if statement and if the condition is false, it doesn't execute the if, it just doesn't execute the code in that block. So it could be all kinds of errors being raised and you don't know what, but you never see that code, right? The same thing here.
What's the, maybe you just said this, but what does that assignment, the evaluation, what does that do in line 16, starting at round to the end?
Round is just like, if I do like x equals 1.2345, like so I print round x2. It just rounds it. Oh wait, what did I do wrong? Oh, round. So it rounds 1.2345 to like 1.23.
So you would change that just by the second 2. Like if you change the second 2 to a 3, we would have 3 decimal places. Or, yeah.
Well, not in this case because it
Doesn't have one.
it doubles evenly to 1.78. But if I did like times 3, I don't know. Is that double evenly? No, probably not.
If you did the one you just did, like round x to at the
Oh yeah, that's an easier example. Yeah, like that.
okay, so it's a decimal. Okay.
Oh, yeah,
Yeah.
there you go.
That was what my question was, and you probably said that. You said something.
Okay, yeah, no, we're good. Okay, so that's it. So any more questions on the break and continue statements? Get them in now because I'm about to ask you to use them. So no, we're pretty good. Okay, let's try it. So I want to say I'll change the wording here because I think people have gotten confused about this before. So, all right, so here is a exercise. Hopefully everyone has the notebook open. So we want to say here's a list of a dictionary of fruits mapped to their prices, and we want to use a for loop to calculate a tally of the price of fruit. So we're just like a summing, like we're adding sum. Okay, plus 30 cents, plus 40 cents, plus 50 cents for each of the prices until we reach $2, 2.00, right? And then you have to use break to quit the for loop once $2 has been reached. Does that make sense? All right, let's give that a try. So let's try to do this here. So we do like we were doing before for fruit in fruits.keys. And then we say we're gonna have a tally that starts at 0 because we don't have any prices that we've added to it yet. So we say if tally is less than or equal to 2, we add the price of the fruit. Otherwise, that's fine. Yep. See, I'm kind of cheating, but that's what I would have written anyway.
So
I swear.
It's not an integer, it's just a...
0 is an integer. 0.0 is a float. But it doesn't really matter because you can add integers to float. When it tells you like you can't add a string to an integer, that's true. You can't add a string to an integer, but it never says you can't add a float to an integer. It just becomes a float.
Okay.
So let's run this. You have $3.27 worth of fruit. Okay, cool.
Just a quick question.
Yes.
Yeah, so if our break was on the other side of the if, you see that
Yeah, you could with
if and then
with the condition reversed. Tally equals 0.0. Yeah. Just like that. Yeah, Copilot did it for me. Like literally I just wrote the comment and it's like, oh, this is how you do that. It's like, yep. Why do we need programmers anymore? All right. You guys are all wasting your time studying Python. No, because who's gonna tell whether the code does it the right thing or not, right? That's the important part.
I was gonna say.
Exactly. All right. So before we move on, go ahead.
Okay, I know that we did if tally less than or equals to 2, but you got 327. You
Yes.
have if tally is greater than 2, but I have if tally is less than or equal to 2, and I still got 327 as well.
Right, because that's what we were just talking about. These are the two equivalent ways of doing this. What we're saying is, if it's less than 2, add to it, otherwise break. This one says if it's greater than 2, break, otherwise add to it. It's just the opposite. So like, I'm telling you like, so I said to you like, if you have at least $10, you can go to the mall, right? Then if you don't have $10, you can't go to the mall. This is just like the opposite. Or corollary, I think, right?
Correlate?
Corollary in propositional logic.
Just listen to it that way.
Yeah. Okay. All right, now this is the important part. This is like supposed to be the whole lesson, but we're already at 8:20. Function definitions. So, what? Is there a compressor going on? Oh, and then it went off. Okay. Whatever. All right, function definitions. Let's move on to function definitions. A function can have any number, including 0, of positional arguments and keyword arguments. So it can have 0 or more positional arguments, 0 or more keyword arguments. And then positional arguments and keyword arguments are the only types of arguments. So it's either a positional argument, it's a keyword argument, it could also just not be an argument. It could be like a bird sitting on your windowsill, you know? Like, So here we have some positional arguments. This is what we've been using so far. Print name and age. It takes a name. It takes an age. This is so simple. So I say print Mateo 42. Oops. And I press the wrong button. And my screen goes blank. Where were we? Function definitions. Oh, there's another exercise here, but we're going to skip it because we took like 40 minutes for the first one. Okay, anyway, back here. Print Mateo 42, and it prints Mateo 42. Great. So this is the first positional argument. This is the second positional argument. They are both positional arguments. There are no keyword arguments. Is everyone following? So Mateo is the first argument. It gets passed into the variable parameter name. 42 is the second argument I'm calling it with. It gets passed into the parameter age. Okay, so now for the rest of it, for this one, we're using the same function, print name and age. So when I call this, it says this is an error, right? Missing one required positional argument, age. So that's actually a very useful error, right? It's telling you like, hey, wait, I can't print the name and age of just Fred. I need his age. So if I put his age, now it works. Take the age away, now it doesn't work. And then just as an aside, here we get into the idea that I think I might touch this a little bit later, but Python doesn't have types, right? There's no types. There are types, but there's no type safety, no type checking. So I could put 0, none here, and it prints 0, none. Because all it does is just print out whatever you give it. So this is not a name, this is not an age, but it doesn't matter to Python, right? So that's just an aside. Okay. All right, keyword arguments are optional. And I don't mean they're optional as in what I was saying, you can have 0 or more. It's optional to include them when you define the function. What I mean is when you call the function, they're optional. And they're defined with a default value for that reason, because someone might call the function without the keyword argument. They're optional, right? So we give them a default value. So if it's missing, the default value is what is used inside the function. So you won't get a name error oh, that parameter is undefined, because it is defined. It's just using its default value because it wasn't called with that value. So here's an example. So now let's just look at the code for a second. So I'm saying all right, I'm going to print the name and the age, and I'm going to add a new line. New line meaning go to the next line, right? So I print it, and if add new line, if that's true, I put an empty print statement which just puts a blank line, right? But by default, it's false. So when I call print name and age Mateo 42, add new line is false, and it behaves just like the above. It just prints name and age, right? Then it says if add new line, well, that defaults to false. It wasn't passed in, so it doesn't happen. We're good. Now this one, Mateo 42, same thing, but now I have add new line equals true. So I've overridden the default value of false, and now I'm calling it with a value of true. So now it will print the new line. And then I have this print after function calls just to show you that the new line was there, basically. This is so here it is with the new line. So I was going to say something else about this. Yes, these are keyword arguments. And then, yeah, I'm not sure. Keyword, go ahead, questions?
Yeah, keyword arguments.
Yes.
Positional arguments. Keyword arguments, I would assume would be the first argument, or no?
No, keyword arguments look exactly like this. It's parameter name, equal sign, default value. Positional arguments have no equal sign, so that was what makes them positional arguments. And then what I was about to say is that you must, when you specify, when you call or specify the function both, actually, I don't even. I should add that. So when you call the function or define the function, in both cases, like here, this is an error, right? Because it actually tells you positional argument follows keyword argument. So you can't have a positional argument after a keyword argument, either when you're defining the function or when you're calling the function. So I do like this, something x, y, z equals 42, n. Like it's going to tell me you can't do that. Oops, it's stuck on this. All right. So it's telling me again, parameter without a default follows parameter with a default. So you can't have like your keyword arguments, and I'm like, oh, here's another parameter that doesn't have a default that is just a positional argument, you know?
So keyword arguments have to come after all position arguments.
Yes. Both when you define and when you call. Yeah.
What are these like isn't that like a security thing? Like if every every dictionary has these, or every function has these, right?
Every function has what?
These keyword arguments, right? Like every one that we create.
No,
will have these as like a default in Python, right?
I mean, not really. No, like I was saying, you can have 0 or more positional and 0 or more keyword, right?
And you can create like a keyword argument for your own.
You always just create it. Yeah, you just put like, give me a word.
Bananas.
Bananas equals 0. How many bananas do you have, right? 0. Just put whatever you want. Now, it's up to you what that means in your code, right? Like,
It's like hidden variables almost, right?
it's optional variables. They're optional parameters, yes. They're not really hidden. It's just more like when you're designing the function, like when I'm designing this print name and age function, maybe mostly it's just going to print the name most of the time, but maybe I want sometimes for it to add a new line. So instead of having like this, and I have to put false here and true here, right? And every time I call it, when I don't want it to print a new line, which is like 80% of the time or whatever, I have to keep writing false, 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 false. So it's like, why can't I just tell Python, by default, I want this to be false? Oh, that's what I'm doing. It's a default parameter or a keyword parameter. And also, especially for Booleans, this actually helps a lot because when I see this function call right here, print name and age, Mateo 42 true, it's like, true what? True that he's old enough to drink, true that he served in the military, what is true? But if I do it as a keyword argument, I can do add new line equals true, and now someone reading this code says, oh, it's going to add a new line when it prints the name and age. Oh, okay, yeah. Like this is to your point of like what we do to make our code more readable, right? Yeah. So yeah, keyword arguments come after positional arguments, and then all right. So you can think of like the positional, just the word positional, right? They're in a position. It's the first argument, the second argument, however many you want, but they're in a position, right? So the third argument is always whatever the third argument is, right? Keyword arguments, now you're addressing them by keyword, right? You're like, oh, I want print equals true, or, lookup database equals false, or whatever it is, or, number of lines equals 25, right? So they're keywords. So the order doesn't matter. You're calling it, and you're using the name of the argument, right? So it doesn't matter where in the argument list it is. Python knows what argument you're talking about because you called it by its name. Database connection equals 1, 2, 3. Like you're calling it by its name. So here, I'm saying I've added like a bunch of new keyword parameters to this function. Now I have multiply age. I can make you older, and how much to multiply it by. So now I'm just saying if multiply age, So by default, if I call this with just positional arguments, just the 2 required arguments, multiply age will be what? What will be the value of multiply age if I call this with 2 parameters? False, right? Because it has a default value of false, right? So that's false, and then it doesn't multiply the age. Go ahead.
Even though you're not saying like true. That's what if multiple. Oh, sorry. Yeah. Okay.
No worries. So then it prints, and then it does the add new line, right? So now when I call this, I can call it Mateo 42, age multiplier equals 3, multiply age equals true, add new line equals true, even though that's the exact opposite order that they were specified in the function definition, right? It doesn't matter, because I'm choosing the name of the parameter to call it with, right? And keyword arguments can also be specified with the same value as their defaults. This is just kind of important to remember that, like, even though multiply age, it defaults to false, I can call it with false, right? Because it would be annoying if I was writing Python code and it's like, oh, this is an error, you called it with its default. It's like, who cares if it's called with the default, right? Like, I don't know, I don't want to go look up what the default is and make sure I don't accidentally call it with it, you know? Like, so let's run this. So Mateo is 126 years old now because he was 42, and we multiplied his age by 3, and we did in fact multiply age. If I change this to false, then it doesn't multiply the age anymore. Mateo's back to being 42. So age multiplier 3 is kind of ignored in that case, right? Which is also kind of the practice of like what happens in Python, because there might be some keyword arguments that are used together. So if some of them aren't true, then the other ones don't take any effect, etc. That's just kind of how you define your functions and your API, you know? So, all right, moving on. Oh wait, this has to be true, or else my example won't work the next time I try it. Okay, and then this, all right, I'm just gonna blow through this because we're already low on time, and this is just silly crap, but you can specify keyword arguments as if they were positional arguments. So I can call print name and age, which is the function we've been using, right? With Kelly 25, true, true 4. And true, true 4 becomes add new line true, multiply age true, age multiplier 4, right? So 25 gets multiplied by 4, true, true 4. So you can call them, if you call them as if they were positional, you basically call them in this order exactly, right? Because now you're no longer referring to them by their name. Okay, great. And that's just kind of in the language so that, like, if you had a function that had a keyword or like had a positional, you can change it to a keyword and existing code still works, right? Because if I was calling it with 4 parameters, now you want to convert the 4th parameter from a positional to a keyword. It'd be annoying to break all like thousands of lines of code and have to go update everywhere because now it's suddenly a keyword, right? In general, when you write the function the first time and you have the positional and the keyword, when you call the keyword, you use the keyword, right? That's good style. But this exists so that like if you changed it from a positional to a keyword, people don't have to go back and like update thousands of lines of code.
So just for a quick example, you could do like multiply age equals multiply age.
No, that's not what I'm saying.
No, right. Okay.
I mean, you can do that, but it's like a whole different feature.
Okay.
What I'm saying is that like if I had like def add x, y, z, and I did return x plus y plus z, I'm calling this, 1, 2, 3, and it returns 6, right? Now let's say I want like, oh, you know what? I always want z to be 10 if they don't put it, right? So now I have some other call like 5, 5, so that's gonna be 20, right? But this one still works because even though I converted z to a positional argument, I can still call it as if it was, converted it to a keyword argument, I can call it as if it were a positional argument. And like I said, the reason for that is that you want to maintain backwards compatibility. So I don't need to go in here and say, oh, now it's z equals 3, right? And then, so we run this, yeah. And then the opposite is also true. I can call the positional arguments by their name and call it as if they were keyword arguments. They're still required. Like the first two parameters here, name and age are still required, but I can like mix up the order and do whatever I want. Again, this is just to like help you write code, extend code. It's just a language feature. It's not important. So I just want to point it out there in case you're like, how did that possibly work? I called the keyword argument with a positional, blah, 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 blah. It's like, this is why it worked. So, okay, we have another exercise here. And this one's a lot easier than the fruit tally. All we're doing here is I'm giving you a function, and I just want you to call it. So you don't need to write any new code that does some new thing. Literally, you're just writing ways of calling this function. So we're going to call it with just the positional arguments, with the positional arguments and one or more keyword arguments, and with the keyword arguments out of order. That's all you have to do. This literally should take 7 minutes. If it takes 7 minutes, I'll be surprised. And I forgot to put a your code here, so just use, insert code block in the Python, in the Jupyter Notebook. So with just the key thing, and then with a keyword argument, and then the keyword argument's out of order. So it'd be like override equals true, override color equals yellow, and then it'll print, oh, what did I do wrong? Print fruit color, that's what it's called. Oh, I never ran this block, okay. All right, now we try it. Apple is red, it prints no known fruit for kiwi apparently, and then it doesn't print anything for this one because kiwi is not known, but if I change it to apple, it'll print apple is yellow, which is funny nonsense. Call me Lewis Carroll. All right, function scope. This is complicated, and I'm not sure if we're up for it. I know the fruit tally exercise took a lot of brain power. So maybe we can review this on our own, but I'll just go over it quickly. Basically, any variable you can refer to without a name error is in scope, in a sense. So if I run this, I get this. This is my price discount example that I use all the time. And then here, okay. So when I say like get discount, blah, 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 prices equals whatever, it's printing applying discounts, and it says for P and prices, get the discount for P. So it's like the discount for $1.50, the discount for $2.10, the discount for $3.29, right? Whatever it is, right? And then I hit print price, and I get a name error, which is this. Name price is not defined. Now, I'm pretty sure most of you are going to yell at me and say, it is defined. It's defined right here. It's right there. Price is right there, right? But I'm going to tell you that when I get here, it's not defined because it's only in scope in the get discount method function, right? So this parameter price and this variable price only exist here. Once I get down here, it just doesn't exist. All right?
Oh, sorry.
Go ahead.
Is it because it's not defined as a separate variable?
Yeah, basically, right. That's pretty much it. It's only defined inside this function. Same thing as if I did like x equals 12 and I tried to print x here. Well, x is a bad example. It has to be like blah equals 12 because I use x in all the other code blocks. But if I do like blah, it's like, oh, blah is not defined. And you might think to yourself, this is annoying. I wish I could just refer to this blah variable down here. Like, what the crap? This sucks, right? But actually, it's pretty useful because inside my get discount function, I don't want to worry about like, is someone using this blah variable? Have they used that name already? I don't know. Have they used it? Are they using it somewhere 1,000 lines away? You know, like you don't want to worry about that. Inside your function, you can define whatever variables you want, and they have scope inside that function.
So how do you reference those things inside that function?
You basically don't. Like the function is doing its own calculations with its own variables, and then you get the return value.
I see. So it's kind of like a domain expansion where nothing goes in or out of it, and it just kind of all stays within its own.
Not quite, because the point of a function is that you pass in the parameters and you get out the value, the return value. So it's not really nothing goes in or out. It's more like while you're in there, you're in your own world. Okay. And then here's an example where I use the same variable in two places. So here I say price equals $1.29, right? And then I pass in $10.59 to the discount, and it prints $8.47 or whatever, right? Because this prints the results of this function, and when I get here, price equals $10.59. Price does not equal $1.29. And actually, this would be better if I then printed price. And it's not a name error. So when I print price, it's $1.29. Even though it was temporarily $10.59 inside this function, it's almost like there's two price variables, you know, like there's like John Smith, no relation, John Smith, no relation, you know, like it's kind of that, right? And then blocks do not interact with scope, blah, 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 which means that if I do have a for loop, and price is a bad example because I've already used it a bunch of times, but like hot in prices. So even though I'm down here, you think, wait, hot should only be defined in this block, right? But actually, it has the value of the last variable it took, or value it took. So like, the for loop is assigning successive values to the variable hot, and then when I get down here, it still refers to the last thing it referred to. That's just something to keep like in the back of your mind. If you're like, wait, how do I even have an X variable? Where did that come from? It's like, it came from your for loop, you know? I want this to be price though. Okay, last thing. We've got 5 minutes. We're never going to get through this. I hope everyone's okay with staying like an extra 5 minutes. Y'all got here at 7:20 anyway, so. Okay, who's familiar with the concept of mutability, or who's heard the term mutable, immutable? Yes, pretty much everybody. Okay, so it's like mutability is what values in a program can change. An object in Python is mutable if it can be changed, and immutable if it cannot. Tuples are immutable. We've already discussed that. Strings and numbers are also immutable. If you assign a number to a variable, it's always the same number. If you later assign a different number to the variable has changed, but the number hasn't, right? So here, x equals 42, print x. X equals 50, print x. X equals x plus 10, print x, right? So like, x is 42, now x is 50, but 42 didn't change, 50 didn't change, x changed. It seems simple, but like that's the point. It's like 42 is always 42. X might have a different value, so again, like this is like. And this is the real tricky part. Strings may appear to be mutable, but the methods on strings actually return a new string. So if I have pineapple, I do p.capitalize, then I print p, like it's not capitalized, right? Why not? I said capitalize it, right? Why is p not capitalized? Because p.capitalize does not modify p. That's impossible. P is immutable. P is a string, and strings are immutable, so they cannot be changed. So p.capitalize just returns a new string. So here I'm doing something different. P equals pineapple, Q equals p.capitalize, then print Q, and now Q equals pineapple with a capital P. Because like I said, p.capitalize doesn't change P, it just returns a new value, a new string.
But why didn't it print it capitalized? Because isn't your print
This one?
after? Yeah.
Because it doesn't capitalize P. It returns a new value that is P capitalized.
How would you access that then?
Like this. Q equals p.capitalize.
You have to assign it.
You have to assign it or use it somewhere, yeah.
Could you say print parentheses p dot capitalize p or?
Yeah, P, you could do that, and that's kind of like the shorthand, so you don't have to have this Q variable. And that works, but P doesn't change, right? P still doesn't change. You're just printing it, and you're saying, like, print whatever P is as a capital, and you create a new string, and it gets immediately printed and then thrown away. Unlike this Q, which, like, Q sticks around. I can refer to Q later. And then here's the tricky one. P equals pineapple. P equals p.capitalize. Print P. So what's this going to print?
A new P, right?
A new P, yes. And what's that going to look like?
It would be capitalized.
It would be capitalized, exactly. Because I'm saying create a new string and overwrite the value of P with that new string, right? It's just like the x equals 42, x equals 52. Like, pineapple didn't change, but what P refers to changed. Meanwhile, otherwise, data structures like lists and dictionaries are mutable, which is kind of half their value, is like half their utility is that, you know, you can add stuff to a list. You can change things in a dictionary. That's how we update data. That's how we do computations. So here, when I have this fruit list that just has apple, lime, and pear, and then I append kiwi, and when I print it out, it should have apple, lime, pear, kiwi, which it does. This one's a little bit surprising. If I have two variables that refer to the same list, so here I assign other fruits equals fruits, right? They refer to the same list. They're pointing at the same thing in memory, basically, right? So then when I append the kiwi and I print other fruits has apple, lime, pear, kiwi. Even though I appended kiwi to fruits, right? I never touched other fruits. Why does it have a kiwi?
What happens if you just print fruits? Fruits also has kiwi.
Exactly. It didn't append to other fruits instead of fruits.
Yeah, that's what I was kind of.
Yeah, no.
The P in the Q from earlier.
Yeah. That's what I'm saying. Like, this is gonna melt your brain, and we only have 5 minutes, but. So the result of this, the consequences of this, is that if we pass a list to a function, and the function modifies the list, we will see the changes in the place where we called the function. So here I have add kiwi. So it's kind of similar setup as before. Apple, lime, pear, I print it. I call add kiwi. Kiwi appends kiwi to its own fruits parameter. Remember, this is not the same as fruits from somewhere else. We already talked about that, right? But when I print the fruit list, it now has a kiwi. And this kind of works the same as this other fruits example, because I'm saying, like, okay, fruits equals fruit list. So now I'm going to append to fruits, you know what I mean? Like, this is the same list in memory. They're pointing at the same thing. And when that list changes, the fruits variable changes inside this function, which doesn't matter because it's about to return. But then also fruit list, where I called it, changes to include the kiwi. But like, this doesn't happen. Oh, go ahead.
And so I noticed it go up variable and then it would be immutable and we can change it, but since it's kind of like a dictionary, we can.
Because, sorry, you're using the wrong terms, but yes. If we used parentheses, it would be a tuple, and then it doesn't even have an append function. That's how we can't change it, right? Yeah. And then, but because it's a list, we can change it.
Okay.
Yeah. And then, not so for numbers. Here we have y equals 42. This is like the exact same setup as up here. You know, y equals 42, print y, add 10 to y, print y again, right? So what does it print? 52? Okay. 42, 42. This is what I'm saying because y equals 42, we pass y to add 10. So now x equals y. They both point to the same number in memory, right? 42. But 42 never changes. So when I do this, notice that I'm not actually modifying 42. I'm just saying x now equals x plus 10. So actually this does nothing. This doesn't change the value of anything. It's kind of like useless code. It's just adding 10 to a local variable and then returning, which doesn't do anything useful. It doesn't do anything useful. So y never got touched, right? There's no reference to y here. Does that make sense? Like x, I'm just adding 10 and reassigning it to x, but we know about function scope. So x only exists here, right? So that's why it doesn't affect y. Whereas in this example, fruits.append, fruits only exists in the add kiwi method, but fruit list and fruits refer to the same list. And I modified that list. So multiple variables can refer to the same thing. That's basically kind of the moral of the story.
I think my only question would be, with the y equals 32 and then we print y which is 42, why wouldn't the add 10 y make that add 10 to it?
I mean, it's kind of a tricky name for the function add 10 because it's like what we think we're adding 10, but we're not.
Okay.
Because what we're doing is we're assigning a new value. So if I print x up here, x equals 52. See? 42, 52, 42. But that doesn't change the value of y. But why does the list get changed? So why don't these operate the same way? Because numbers are immutable and lists are not. That's the fundamental reason. But also you can think of it as like, I'm calling dot append. I'm modifying the thing, not the variable. I'm not modifying the variable. Variable equals blah modifies the variable. But when I just call dot append, I'm modifying the value, the thing that the variable is pointing at, right? Whereas here, I'm not doing like 42.add 10 or whatever. You know what I mean? That doesn't exist. Okay, and we're gonna end it there. Any last questions? There's a whole thing about args and quarks, but I think I'm gonna do that one. That worked well when I did decorators, so it's good to save for that. Cool. Well, you guys all did really good today. I know the exercise was challenging, but everyone kind of made it through it, which was great. It's good to see, so I appreciate you guys. And I have to say this at the end of every class. This class is free. I am a volunteer. I do not get paid, but Noisebridge runs on donations, so if you got something out of the class or appreciate being at Noisebridge at all, please make a donation. You can do so on the website or with some of the posters that are hung around the space. Thank you. Thank you.